Hey everyone! In this video, I want to look at a couple examples where we need to use some specific strategies in order to evaluate a limit. We know that there are a lot of limits we can evaluate simply by plugging in the value of c, and that will give us our limit. However, that doesn't always work, and that's what I want to take a look at in these examples. So let's take a look at this first one. The limit as x approaches -2, and then I have a rational function. So again, a rational function is just one polynomial divided by another one. So the important thing to note here is the domain of this function. So the restriction we have is we just can't divide by 0. So anything that would make the denominator 0 is excluded from the domain. So our domain here is all real numbers, except x cannot be positive or -2. All right. Now, if I take a look at my value for c, what x is approaching, that's -2. So that's not in the domain. So that means we have to use a different method to evaluate our limit. Just to show you what I mean here, if I just try and simply plug in -2, so plugging in -2, let's see what we end up with. Okay, so in the numerator we have 4 minus 10 plus 6. And in the denominator we end up with 4 minus 4. So we end up with 0 over 0, which is undefined. So if you just try this out and you plug in -2, maybe that leads you to think that maybe the limit doesn't exist, or the limit is undefined, or something like that. But it's not. So the way that we want to handle this then is if I notice that my value for c is not in my domain, I have to work with the function a little bit. Now the first thing we should check is to see if we can simplify it at all. So let's try factoring it. So what we end up with here, so I'm going to carry over my limit. It's important that this follows me along in every step. And if I factor the numerator, two numbers that multiply to 6 add to 5, we have x plus 2 times x plus 3. And in the denominator, that's the difference of perfect squares. So we have x plus 2 and x minus 2. So now that we're in factored form, we can see that we have a common factor in the numerator and the denominator that's simplified. So we end up with the limit as x approaches -2. So those cancel out, and we just have x plus 3 over x minus 2. So now that it's simplified, we can plug in -2. So -2 plus 3, and then -2 minus 2. And it looks like we end up with 1 over -4. So altogether, the limits as x approaches -2 of our original rational function, this is equal to -1/4. Okay, so even though our value for c is excluded from the domain, even though our function is undefined at that point, the limit still exists. The limit is -1/4. Let's look at one more example where we're going to use a different strategy to find the limit. So here I have the limit as x approaches 5 of the square root of x minus the square root of 5 all over x minus 5. So again, if I just try and plug in 5 to evaluate this limit, I end up with the square root of 5 minus the square root of 5, and then 5 minus 5 in the denominator, which gives me 0 divided by 0. So again, it may seem like this limit doesn't exist, but there are ways we can work with this and we can actually solve it. So as I said before, the first thing we should check is to see if we can simplify. This one, there's nothing we can factor, so we need to use something different. I do have some square roots here. So what I want to do with this is I'm going to multiply by the conjugate. So remember, the conjugate is if this is square root of x minus the square root of 5, the conjugate is going to be the square root of x plus the square root of 5. So let's just take our rational function here, and we're going to multiply by the square root of x plus the square root of 5. And then we're going to do that on the top and the bottom. So just a note here, this is all happening within the limit. It's like I'm multiplying by 1, so I'm not changing any values here, but I just wanted to note that this is all happening on the inside. The reason we can multiply by a conjugate, or the reason we want to, is because 1 is plus and 1 is minus. This is going to simplify really nice. So I need to multiply this all out. So I'm thinking about this like these are in parentheses. So what we're going to end up with, so I still have my limit. In the numerator, square root of x times the square root of x is just x. In the middle, these terms are going to cancel out. We'll have a positive square root of x times the square root of 5 and a negative square root of x times the square root of 5. So then we'll have minus, and then the square root of 5 times itself is just 5. And then in the denominator, I'm going to leave these factored out. So we have this x minus 5 times our two radicals here. And this worked out pretty nice for us because after multiplying by the conjugate, rationalizing the numerator, I'm able to simplify. I have a common factor of x minus 5 in the numerator and the denominator. So we end up with the limit, as x approaches 5, of 1 over the square root of x plus the square root of 5. And just like we saw in the last example, 5 is no longer excluded from the domain of the function I'm left with. So now we can just substitute that in. So 1 over the square root of 5 plus the square root of 5, and we can combine those together, 2 square roots of 5. So to sum that up, the limit as x approaches 5 of our original function, this is equal to 1 over 2 times the square root of 5. So again, just to reiterate, 5 was not part of the domain, and if we just try and plug in 5 initially, we ended up with 0 over 0. Well, that doesn't mean that the limit doesn't exist. We can work with it a little bit. Here we multiplied by the conjugate to rationalize the numerator, and then we were able to simplify, and we were able to find the limit.